Welcome to the Lionheart Academy. This is Richard Tai, and we're back here for our next lesson in trigonometry. Last time we talked about basic measures of angles in degrees and in radian. Today, let's continue this topic on measure of angle. So, let's go ahead and get started with the quadrants. Okay, I know we have been using quadrants already, but we've been using our coordinate plane, but we haven't really talked about the quadrants. Let's go ahead and connect the quadrants to the measures of angles, because our measure of angles is tied to standard positions. So we got to go ahead and talk about this. So again, our x-axis is right here. Okay, this is the positive part of x-axis. This is the negative part of x-axis. This is the positive part of the y-axis. This is the negative part of y-axis. Okay, and so as you can see, the coordinate plane is divided into four parts, four regions. Okay, the upper right-hand part is called quadrant 1, where both x and y are positive. The upper left is called quadrant 2, where x is negative. Okay, as you can see, this is the origin. So the x-axis here is negative, but y-axis is positive. In quadrant 3, both the x value and the y values would be negative. And in quadrant 4, x would be positive, but y would be negative. Okay, and as you remember, if we talk about the degrees and the radian measures of the quadrants, okay? So the positive x-axis, when you are at the initial side right here, you have a 0 radian, okay? At a 90-degree angle here, this is pi over 2 radian. At 180 degrees is pi radian, and then at 270 degrees is 3 pi over 2 radian. Okay, and when you come back to the 0, when you make a full rotation, you're at 2 pi radian. Okay, so in quadrant 1, all the angles are between 0 and pi over 2 radian. In quadrant 2, all the angles will be between pi over 2 and pi radian. And all the angles in quadrant 3 will be between pi and 3 pi over 2 radian. 3 pi over 2, which is also 1.5 pi, if you think about that. And in quadrant 4, all the angles will be between 3 pi over 2 and 2 pi radian. Now, this will be very important in our lessons to come. So it's good to understand, to familiarize yourself with the quadrants and what angles they are. And if we go ahead and put a degree, if you want to go ahead and put the degrees on it, this would be starting with 0 degrees, and this would be 90 degrees on top. Okay, 180 degrees to the left, 270 degrees down, and then coming back, this would be 360 degrees to complete a whole revolution. Now, as you notice that 0 and pi over 2 and pi and 3 pi over 2 and 2 pi, they are not part of the quadrant. And they are actually called quadrant angles because they divide the quadrants, but they are not in the quadrants in themselves. So that's something we can pay attention. Now, okay, let's go ahead and talk about some common angles that we would need to know in the quadrants. Okay, so let's go ahead and draw a big coordinate plane here. Alright, again, so this start with 0 radian, pi over 2 radian, and then pi radian and 3 pi over 2 radian, and coming back, this is 2 pi radian. Alright, so let's think about some common angles that are important to us. Let's say if I divide, okay, I'm just going to change the color blue here. Let's say I'm dividing the first quadrant by half. Okay, if I divide this by half, this angle right here would be half of pi over 2. So what is half of pi over 2? Well, if you divide half pi over 2 by 2, is pi over 4. So halfway between 0 and pi over 2, you have pi over 4. Okay, and as you can see, what will happen is, what we can do is we can actually divide the whole coordinate plane by quarters. Okay, so in a sense, we're dividing the whole circle, whole revolution, into 8 equal parts. So pi over 4 is 1/8 of the revolution. So you have 1 pi over 4, and this is 1 pi over 4. This is 2 pi over 4, which is pi over 2. So this angle will be 3 parts of that pi over 4. So this is 3 pi over 4. Okay, and when you go ahead and revolve to pi here, this is 4 pi over 4, which is 1 pi. And so if you keep going, and this would be 1 pi over 4 more than pi, so it's 5 pi over 4. And then this one would be 6 pi over 4, which if you reduce it in your fraction, it would be 3 pi over 2. Then next one, this is going to be 7 pi over 4, because that's the seventh part of this pi over 4. And then coming back to 2 pi, that would be 8 pi over 4. So as you can see, we can divide the quadrant into 8ths. So the whole revolution is divided into 8 equal parts. Each part is pi over 4, and you can count by pi over 4 as 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And you can keep going. We haven't really talked about this. You can keep going. The next one would be 9 pi over 4, which is the same as pi over 4. So they are coterminal angles. Again, coterminal angles means two angles that end up in the same terminal side. For example, this angle is pi over 4. However, but if I go ahead and complete the whole revolution and then come back here, the green angle would be 9 pi over 4. It ends at the same terminal side, but because of the revolution it made, so it's actually went through 9 pi over 4 revolution, 9 pi over 4 radian, which is one revolution, a little bit more than one revolution here. That's why they're coterminal angles. So that's one thing that we can understand is coterminal angles. Okay, so this is the basic is pi over 4s. All right. Now let's take a look at another sets of angles that are very, very common that we need to use. Let me use another coordinate plane so we don't get confused. Okay, let me go ahead and draw it here. All right. Again, we have our coordinate plane here. Let's start with x, positive x-axis, and this is labeled the y-axis, and again this is 0, this is pi over 2, pi, and 3 pi over 2. Now it is very important for you to familiarize yourself with this, and eventually we'll develop this into a whole unit circle. Alright, so we divided everything into 8 parts. Okay, another way to divide this is divide this into the whole quadrant excuse me, the whole revolution into 6 parts. Oh, actually, let's divide pi into 3 parts. Yeah, in fact, let me go ahead and do this. No, I'm sorry. Okay, so as you can see here, this is like a pentagon, excuse me, not pentagon, but hexagon. We're dividing the whole revolution into 6 equal parts. Okay, so because each revolution is 2 pi, you divide by 6, it will be pi 1 6 would be pi over 3. 1/6 would be pi over 3, and this would be 1 pi over 3. This is the second part would be 2 pi over 3, and this would be 3 pi over 3, and this guy would be 4 pi over 3, and this guy would be 5 pi over 3. Okay, and then coming back to 2 pi will be 6 pi over 3, which would be 2. So this is another way to divide this revolution, and then those angles are very common angles, are very useful angle as well. Now one more way that we can do is, a lot of times we do it, is dividing every pi over 3 into halves. So which means that we're dividing them into pi over 6 parts. So like that. Okay, this is half a pi over 3, which is pi over 6. Let me use red so that we can see a little bit better. So this is pi over 6. This actually is 2 pi over 6. If you come to think about it, 2 pi over 6 is pi over 3. This is 3 pi over 6. 4 pi over 6, and this one will be 5 pi over 6. But 5 pi over 6 cannot be simplified, so we simply leave it as 5 pi over 6. This is 6 pi over 6. This one will be 7 pi over 6. So basically, we're just counting by pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, and this one will be 11 pi over 6. And coming back to the full revolution would be 12 pi over 6, which is equal to 2 pi, right? 12 divided by 6 is 2. So that is another common sets of multiples and angles that we will be using. And we'll be talking about what degrees are they, and we can actually convert them into degrees. Now, just before we go on, want to make sure before we talk about the conversion between degrees and angles and radians, just want to make sure that we understand the word complementary and supplementary. This is just quick review. Complementary means the two angles sums up to 90 degrees. The sum of the two angles equal to 90 degrees or equal to pi over 2. That means complementary. And supplementary, the word supplementary or supplementary means the sum of the two angles equal to 180 degrees or equal to pi. Okay, so just want to cover this two vocabulary before we go on. Okay, all right. So last part of the lesson today, let's go ahead and talk about conversion between radian and degrees. Okay, so conversion between radian and degrees. Alright, so as we have mentioned before, 1 pi radian is equal to 180 degrees because it has a half a rotation. A full rotation, 2 pi radian is equal to 360 degrees. So this is going to be our main conversion ratio. So let's put them in a simple formula. So if I have a degree, I want to convert to a radian, or if I have radian, I want to convert to a degree actually. So degree measure would be a radian measure times 180 degrees divided by pi, because that is the conversion ratio. And if I have a degree, I want to convert to radian, I multiply by the reciprocal of this by multiply by pi over 180 degrees. So those two are your basic equations. Now, how do you remember this? Very simple. If you want your degree, if you want the answer to be in degree, you put 180 degrees on top of the ratio. If you want your answer to be in radian, you put pi on top of the ratio. Okay, so this is the basic equations that we can use to convert radian to degree and degree to radian. Alright, so let's practice some examples here. Alright, let's say we want to convert 135 degrees to radian. Alright, to radian measure. But let's say, how do we do that? Now, radian measure actually has no units. Okay, you will see what happens. But let's go ahead and do this. So what we do is we multiply by the conversion ratio. Now, because we want the answer to be in radian, so we put pi on top, and we put 180 degrees on the bottom. So 135 degrees times pi divided by 180 degrees. Okay, so this would be 135 pi divided by 180. The degrees cancel out. Now, 135 and 180 can be reduced. Okay, you can reduce them by, I think they have a common multiple of 5. You can start with 5, right? So 135 divided by 5 is 35, right? And divided by 5, no, it's be 25. 27 actually, I'm sorry. And then 180 divided by 5 is 36. So 27 over 36, and you can see that they have a common factor of 9. So you keep dividing, you reduce it by 9. 27 divided by 9 is 3, 36 divided by 9 is 4. So the final answer would be 3 pi over 4. Okay. Now, what if I have a negative angle. Let's try negative 270 degrees. What if I want to convert that to radian? So I multiply it by the same ratio, 180 degrees. So here we multiply by negative 27 pi over 18. We reduce 270 by 10, reduce 18 by 10. Now as you can see here, you can keep reducing by 9, and so this would be 3 pi, and reducing this by 9, it will be 2. Okay? Alright, now let's go ahead and try some examples here from negative, let's go ahead and try it from radian, convert to degree. So when you go ahead and convert radian to degree, you would have to divide, you have to multiply by 180 degrees over pi. So here, the pi and pi cancels out, so you have negative 180 degrees divided by 2, which is equal to negative 90 degrees. Okay? Now, let's try another one that doesn't have pi here. Let's say we want to convert 2 radian to degrees. Well, you have to take 180 degrees over pi. So, this would be approximately equal to 360 over pi degrees. So 300 degrees over pi. And that is not a whole number, but if you go ahead and type in the calculator and work it out, it's approximately 114.59 degrees. Okay? Alright, so today let's go ahead and stop right here. We're going to continue our discussions in the next lesson. Please leave any questions and comments below, and we look forward for you to join us again. Thank you.